Okay. So what we typed before, we saw kernel map for 3 variable, and this was an example that we have done together. Do you remember this example? What we did here, we selected, we saw that there is 3 implicants. Everybody, please. This quiz is finished. Please come here. We saw that there is 3 implicants. Here you see 1, 2, 3. There are 3 implicants, but 2 of them are essential. This one is essential because it has something that is not covered by any other implicants. This one also is essential because it has something that is not covered by any other implicant. Okay? You're not with me. Are you doing quiz or something else? What are you doing? Be here, everybody. Pay attention. Okay. So this was the last example that we have done. So when we wrote these 2 implicants, then all of the ones are covered. So we don't need the other implicant, and we removed it. So the simple function would be BC plus AC naught. Okay. Now let's go to the next example. This is the next example. You see, in our truth table, we have 1, 2, 3, 4, 5 ones and 3 zeros. And we have to write it as a standard sum of product, which we have written here. This is the SSOP, a standard sum of product. So the terms of 1, 3, 4, 6, and 7. These 5 terms are there. And we have to start from this. And we put them in our kernel map. So if you remember, let me write down for you. This was 0, 1, 2, 3, 4, 5, 6, 7. So these are the kernel map cell numbers. What could I do that you don't do the quiz anymore if you are doing quiz? I don't know, maybe you are doing something else. So this is the kernel map. Number 1 here, number 3 here, number 4 here, 5 is 0, 5 is 0, 6 and 7 are 1. So we have transferred our truth table to kernel map. Now it's time to find the implicants. So somebody suggests me an implicant. From that side, that corner, yeah, very good, very, very at the far end. Suggest an implicant here. This is the kernel map, yes? So now we are going to find implicants. Suggest an implicant. Yes, please. Okay, first give me which should I mark, and then tell me the midterm, the term. Which should I mark? If I number them, please tell me which numbers should I. 1 with what? 1, okay, 1. Then, so what? What about what else? 1, 3, okay. 4 here. Oh, it's they are not adjacent. So they are not in one implicant. No, just 1, 3, okay. So 1, 3 is an implicant. 4 is not adjacent to this term, so we cannot use it. And even, what about 7? Justin, what about 7, your point? It doesn't work, because these 3, they are adjacent, but they don't have a common thing, because this one is just 1. If also 5 was there, then okay, we could select the 4 together. But we cannot select 3, because they don't have adjacent terms to get to each other. So only what? 1 and 3. Okay? This is this one. What else? Somebody else. Okay, please. You could you please tell me more implicants? So 1, 1, 3. What about what else? What else?
So 1, 1, 3. Could we do like a row, like an implicant that in case is like all 3 of the ones along the bottom?
3, no. Because if you select these 3, then let's see what happens. Justin was mentioning that point before. So let's see what's it. What is this one? This one is A naught, B naught, C. Okay? This one. What is this one? This one is A naught, B, C. Okay? And what about the next one, this one? It is A, B, C. So if you look at these 3, then you cannot find any common things between them. So you cannot do any kind of simplification. This one is making things bad for these 2. If it was only these 2, then we had A naught C from these 2, which we could select, and then A naught C and with B plus B naught, which would be A naught C. But when you add these, then you don't have any common terms between these 3. So we cannot select it. But here, let's say if it was 1, then we had another term, which was A, B naught, C naught. Okay? A, B naught, C naught. Oh, they are very confusing. Let me erase something so we could see what's happening here. Okay, now we have these 4. Please pay attention, everybody. We are considering that we had a 1 here. I am saying that we could select these 4. Why? Because you see, if you have these 4, you have A naught, B naught, C, A naught, B, C, A, B, C, A, B naught, C naught. From these 2, A naught B, no, A naught, yes. From the first 2, we have A naught C. So it would be A naught C from the first 2, B naught. From the next 2, we have, maybe I did wrong, it had, yes? That's what I am looking. This one, this one, this one, this one. A, B naught, C. Wow, yeah, that's the problem. No, that was the other one. No, that was the other one. No, the last one, the last term. So this is ABC corresponding to this, and for this one, it should be A, B naught, C. Okay, so this is correct. Yeah, now it's okay. Now, what do we have? From the next 2, we have AC in common. AC. From here, we have A naught C. From here, we have AC. So again, A is gone, only C. So if there are these 4, it means C. You know, the C is common between all of these 4. But let's go back to our example. In our example, we thought of this implicant and the next implicant. And what else? What other implicant that we could see here? Yes? A, C naught. C naught is this, A is this, and A, C naught. You mean this, yeah? You mean this, yeah? Oh, A, C naught is here. A, C naught, we have already put it. This is AB. AB is also an implicant because you see these 2 1 together, they are AB. Okay, so this map has 3 implicants. 3 implicants. Which one is essential? Yes.
Would C be
BC.
Yeah,
BC is,
Or sorry,
yeah, BC is these two. Yeah, you are right. BC also, perfect, very good. So we have 4 implicants here. Yeah, these two also are implicant. Very good. So we have 4 implicants here. These two plus this plus this. What else? No, there is nothing more. Okay. Now let's go and find the essential prime implicant. The first green one is essential because it has this one which is not covered by anything. Let me put another color here for essential. So this is the first one. The other green one, it has this which is not covered by anything. So this is also essential. Now let's look at this implicant. It has 2 terms. One is with this one, the other which is already covered. The other one could be covered with this implicant. So it is not essential. Also, we have this one which has 2 terms. One is covered by the first term, and the other could be covered by this one. So this is also not essential. For our essentials are only those 2. Yes, please.
what do you mean by doesn't covered by anything?
Okay, for example, this one, look at this. Look at this term. So who covers this? Only this implicant. So this implicant is essential. Okay? Because it has something that nobody else covers it, it means that it is essential to be put in the function, this implicant. It should be there to cover this. But let's say this one, this implicant. We had 2 more implicants. Let me put blue, this and this. Okay? These 2 implicants, they are not essential. Why? Because they have, for example, this one, the vertical one. It has 2 cells, this one and this one. This one has already covered by this one, and this one has been covered by the other one. So it is not essential. It is a prime implicant because it has not been fully covered with another implicant. It is a prime implicant, but it is not essential. So our essential now is these 2. And I told you, first we pick these 2 essential and we write it. So let's say this one is C A naught. This is A naught C. And this is A B. This is C naught with A. Okay, so we have already covered these 2 essential prime implicant. C naught A. Okay. But we have one left. So what to do with this? Our essential implicants didn't cover it. Yes. You're right. If it was AC, it could be combined with the previous one. Yeah, AC naught. That's right. This is C naught. This is C naught. And this is A. This is A naught, if you want, and then B and B. Okay. So we have one here which is not covered. Oh, you should pick one of the implicants. We had already other 2 implicants. They both could cover this one. It's up to you. Which one do you want to select? Either this implicant or that implicant. Whatever you want. But we have to select something to cover that one. That one is left. So we have to put something. Let's say I select this one. If I select this one, it would be BC. BC. This is BC. You might select the other one, this one. If you select the other one, that would be A, B, A, B. So either BC or AB. One of them would be enough, not both of them. So our function would be A naught C plus A C naught, or with either BC or either AB. So this was an example of two possible solution. So you could select either this one or that one, would be either AB or BC. Yes.
Don't we just look at the parameters, like the ones on the outside that are not fully covered, to get the most minimized?
You mean AC naught? We already selected essential prime implicant, which should be there for sure. You cannot ignore them. But when we selected this, we picked this. There was one which is not already covered by essential prime implicants. So we have to select another prime implicant which covers this.
Aren't they both being covered by the one on the top and the one on the side, which cover them twice?
The one that we are talking right now, you mean this?
Yeah.
It is not already covered with these two essential prime implicants. So it is left, but we have to cover it. So you select another prime implicant which covers this, and we have two options here. You could either select this prime implicant or this prime implicant, whatever you want. It's up to you. There is no difference. Both of them have two terms, and okay. So the design would be this. This is AC naught A naught C plus this, and if you select, for example, this one, I selected AB here. So AB, this is AB. We have AC naught, A C naught here, A C naught, not A naught C naught. We have AB, A C naught, and we have A naught C. And then they are all ORed together. All of them are ORed together. The thing about Carnot map is the final function that you reach is some kind of SOP. It has SOP. You see, it has here three terms, an SOP of three terms. So this is always the final function of Carnot map, and it could always be implemented using an AND circuit, and at the last stage we have an OR, which sum them together. The AND part calculates the terms, the product terms, and this OR calculates the sum. This is a Carnot map. But sometimes we could do something with the last, even with the final function of the final fact. I already told you that Carnot map is going to be the most simplified version. But what I meant is the most simplified in terms of SOP. But you could do something. For example, here you see from AC naught AB. We have AB here, we have AC naught here. You could use these two and make A is common between two. So you make A time A and with C bar plus B, okay? So this is somehow simpler than this one, because it has 1, 2, 3, 4, 5 literals. That one had 6 literals. And if you design the circuit, if you draw the circuit, it will do something like that, okay? In terms of gates, they are the same, even if it has 1 literal less, but in terms of gates, 1, 2, 3, 4 gates, 1, 2, 3, 4. So they are the same number of gates. This simplification didn't help us anything in reducing the number of gates. And also, it has a very bad thing here. I will show you. Even if we change this to this statement, it now generates a 3-level delay for us. We will talk about delay later. But if you look at W from each of the variables, to reach to W, you should pass 2 gates. Everybody, you see, you are following? Don't consider not. So not is very short delay. Not nothing. But C is passing 2 gates up to reach W. Here, from this path, also 2 gates. And B, for example, from this path, 2 gates. You see, all of the inputs are passing through 2 gates to reach to W. So if we say, for example, each gate has 4 nanosecond delay, then it means that we have the maximum of 8 nanosecond delay here. But look at this circuit. This circuit has a path with 3 gates. Look at here. Where is that? Where is the 3 path? Oh, okay, here. This B coming here. And then from here goes to this, and from here goes here. So this path has 3 delay slots. If let's say I told you that it has 4 nanosecond each gate, so this design has 12 nanosecond delay, which is worse than the other one. So it means that it's not true that you do some simplification and you get something better. Here we did something, but it didn't help us, nor neither from the point of the number of gates, and nor from the delay, and even it worsened the delay. So this was another point. Now let's go to the next example. Yes. For the time being, yes. For the time being, yes. Yeah. Don't change the final output of the Carnot map. Keep it as it is. And it has 2-level delays, and it is very good in terms of delay. Now let's go to the next example. You see here, I didn't write the truth table for you. Just put in the Carnot map. And this is a SOP of terms 0, 1, 2, 3, 4, 5, 6. So this is an SOP of 0, 2, 3, 4, 6. How could we simplify that, minimize that? Yes?
One of our implicants could be negation of C.
Which one?
For that Carnot map.
Oh yeah, all of them are, yes, you're right. Exactly, that's what we are going to do right now, exactly. So you found a map with 4 ones, and they are all together. So this example is just showing you some kind of 4 ones. Up to now, we had 2 ones. Here is 4 ones, and that's C naught. Very good. So if you look at this, we could even find 4 ones or either 8 ones. If it is 8 ones, then it means 1. So it's nothing. But here we could see 4 ones. And as we already talked at the beginning of the class, you could combine 2 terms, 4 terms, 8 terms, 16 terms, so on. Not, for example, 6 terms. You see 6 ones together, you cannot combine them. But you can combine 8 ones together. So the first a combination, what was your name? I forgot. I knew before. David, yeah. David. As David mentioned, these 4 ones, they are common in one term, one literal, and differ to the other one. And that would be C naught. So there it is C naught. If you write the mean terms for these 4, you could see that the result would be C naught. Okay. So this is the first implicant that we selected. What else do we have? Another implicant, it's obvious, yeah, this one, the vertical one, which is A naught B, yeah, A naught B, and this one. Now, which one is essential? Do we have other implicants? No, we don't. So which one is essential? I guess both of them, because the first one, the horizontal one, has these, which they are not covered by anything else. So this is essential. And the vertical one has this one, which is not covered by any other implicant. So both of them are essential, so we write it. It's easy. It was easy. The function would be C naught plus AB. C naught plus AB. C naught plus AB. Now let's go to the next one. Oh, the next one is what is very easy. You tell me, what is it? Just 4 ones together. Yes? A naught. A naught. Perfect. A naught. These 4, they are common in A naught. So the result, and this is essential. This is only one implicant, so it is essential, and it covers everything. So A naught. So it means that you could select 4 cells, 4 ones together. Now let's go to another example. Here we have 0, 1, 3, 4, 5, 6, which is like this. Now tell me about the implicants. Tell me. I guess you would say this. Okay. You would say this. Okay. What else? You mean this one, yeah? Okay. And this one. But my point is, because we had a 2D map, we couldn't exactly put the adjacent terms together. Look at these 2 columns. These 2 columns, one of them is 0, 0. It is A naught, B naught. The other one is 1, 0, which is A, B naught. So these two columns common have B naught in common. Is that right? If we could somehow put them together, they should be together. So this is our Carnot map here. Look at the first 2 rows, which is here. I draw it like that because we are going to see the 4 variable map also. But for 3 variable maps would be this one. Our map has 8 cells. So this is our map. And as you could see here, if you put them like that, it is a curve. So these 2 columns also have adjacent terms. Okay? And for selecting the implicants, we could select these together. And that makes us like, oh, this one was easy, this one was easy, and the next 4 ones would be circular, would be this. Now look at that. Then the 4 ones that we have here, these 2 and these 2, they are actually adjacent. If you look at the combination, the right one is A, B naught, the left one is A naught, B naught, so it means that B naught is common, and if you select all the 4, the result would be, Chloe, our expert, these 4 would be B naught. No, B naught. Yeah, you're right, B naught. So it's B naught. Exactly. So you could select these 4, and it is B nuts. And if you look at the essential ones, this green is essential because it has this star. The star means that it has something that's not covered by anything else. The other green one is essential, and also the 4 ones, the blue one is essential because it has these, two ones that it's not covered. So we should write now. Our function would be two term, because it has two terms, and one term, which is B naught. So this would be the result. This was another example to show you that you should consider the map like this. So these 2 columns also they have B naught in common. So you could put them together and make this 4. Now let's summarize what I've told you up to now. So you start with Carnot map, you find prime implicants, then you find the essential ones, then you select them, you put stars for those that are not covered by anything else, so they are essential. And then if there is any terms which are not covered by your essential ones, then you have to select other prime implicants. We try, with Carnot map, we try to cover all of the min terms, all of the ones in the Carnot map, and try to make them combine to make it as fewer as possible maps, and it makes them a larger map. Now let's go to 4-variable map. We have talked about 2-variable, 3-variable. Now let's go to 4-variable map. Again, in 4-variable map, it seems that we can somehow put them on a 2D map. Because in a 2D map, you can just put not more than 2 variables in either horizontally or vertically. So the first 2-variable map, we used a Carnot map which had 1 variable in each side, 1 horizontally, 1 vertically. For 3-variable map, we had a map which has 2 variables horizontally, 1 variable vertically. Now we have 4 variables, so we have 2 variables horizontally, 2 variables vertically, and these are A, B, and C, D. If, again, the same numbering that we had, we start from 0, I write it here, then we will look at it. 0, 1, 2, leave the third one, and then come back. Then 4, 5, leave the third one, then come back. 6, 7, now it is the third column, so we leave it. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12, 13, 14, 15. So I made mistake here. So the numbers not correspond to the min terms. Okay, so that's the right numbering. Now that numbers are just no. What's like that? I guess I made mistake. Yeah. These 2 should be swapped. The last 2. 8, 9, 10, 11, 12, 13, 14, 15. Yeah. These 2 just should be perfect. Okay. So this is 4-variable Carnot map. Like what we told you in the previous one, here exactly again you try to find adjacent ones. But remember, adjacent ones of groups of 2 or 4 or 8. Not 3 adjacent ones, so they don't come to the common term. So now let's see some examples. Oh, okay. And here, as I talked for you about in the three variables that I said that it is a curve map for a 2D curve to have a circular map. We did it like that. But in a 4-variable map, for a 4-variable map, for 3-variable map, we have 2 rows, so they were adjacent. We didn't have to do anything else. But for 4-variable maps, we have 2 rows at top and bottom, and they are also adjacent. So we should also consider this. Something like that. So these are also adjacent again. So either horizontally and vertically. In 3-variable map, we had it circular curve. Here we had a spherical terms, a curve. So it would be something like a torus. You look at here, you see, let's see some of them. For example, this is 1010. 1010 is where? 1010 is here, this dot. This is 1010. And here we have 1000 at bottom of that. 101000. 1000. It's this one. You see, these 2 dots, so this is this one. No. One zero is this one, and 1000 is this one. You see, they are not adjacent. At the first look, you might think, okay, this is here, they are not adjacent, but they are. And even these two are also adjacent. And as we told you in the 3-variable, these 2 are also adjacent. These 2 are also adjacent. And if you have all of these 4, these 4 will make a map, and they are together. They can be combined together. And the rest, we could find it in the map. For example, let's see some examples. This is an example. We have a SOP of 1, 2, 3, 4 zeros and 12 ones. So that would be mapped to this Carnot map. If you look at that, it's 0, 1, 2, 3, 0, 1, 2, 3. Then we have 4 and 5, 4 and 5. And then we don't have 6. We don't have 6. And then we have 7. 7 is here. Then we have 8, 9, 10, 11. 8, 9, 10, 11. And then we don't have 12, 13, 14. 12, 13, 14. And then we have 15. 15. So this is the Carnot map of that table. Okay? Agree? Okay. Now let's find the implicants. The first implicant, you could tell me, or I select something. Let me first. The first one that I select would be this 4. I wish the 0 at the bottom was 1, then I could select all of the 8. But okay, that's 0. So this is the first one. The next one would be, let's put it another color. This 4. But I have to tell you something later about this 4. Could you guess? Perfect. This is what I was looking for. This and this, they are adjacent. I told you could look at that. So you could select these 2 together, and they are both orange, color orange. Let's find something else. What do I select more? Yes.
So like the third row.
CD. have, okay, let's put it this so I could find out easily. CD. What else? The next color. For example, yes, A naught, C naught. A naught is this, C naught is this, yes, these four with red. A naught, C naught, these four. Yes, done? That's all, okay. What else? A naught, the whole thing, A naught. No, this zero is, if this zero was 1, then A naught was right. But this zero making it bad. I could select the 4 ones at the corner. I told you they are all together. So let me select, for example, the purple. So these. So they are also together. So the purple one. Okay. What else could we select? Oh, here. Oh, okay. For example, look at this. Another color, dark red. So look at these 2-1 and these 2-1. So they are also could be combined. Yeah, so it's getting more complicated. What else? Oh, we didn't write this one? No, okay, there is no one. Yeah, yeah, it's okay. I don't see more, but there might be. If you find, let me know. No, so now it is the first one, these 8 together. Okay, that's it. But we find more. There were more. Okay, for example, this one also. So let me erase those who has already covered. This one. Okay. I didn't need these two because they are already there. It was not prime implicant. So I don't need that. This, and that. Okay. So what else? In this figure, we don't have this one. We have already picked that. We don't have this, the red one. Okay, so it was not complete. But they are essential because they have something that no other prime implicant covers that. So they are essential. These 3, the green one, the blue one, and the gray one. These 3 are essential, okay? And when we select these essential, what is left? What is left? Nothing? Nothing. Oh, that's why we didn't draw the other 2. These other 2 is also prime implicant. Let me show you. This one, this is also a prime implicant, but it is not essential because all of its elements are already covered. Also this with that. This is also prime implicant, but it is not essential because all of them has already been covered. So we found 3 essential, and using these 3 essentials, all of the ones are covered. So that's it. We write it. So the 8th one here is B naught, and the green one is A. The green one is A naught with C naught. A naught, C naught. So this is the one. A naught, C naught, green one. And the gray one is gray. Don't we have gray here? No, we don't have gray. Okay, dark red. This one, CD. Okay. So this function has 3 terms with 5 literals. Okay. More examples. Now, the previous example, we had our essentials covered everything. Now I bring another example that we need more than essential prime implicants. So the first one. So this is the map that we would like to minimize. You see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 ones here. We have to find the implicants. Okay, you could tell me, or we could go faster. This is the obvious one. This is obvious. What else do we have? You tell me. In addition, these two, do we have any four one? No. Now we have to go to the 2 ones. Yeah, with the two variables, two cells. Yes, I guess that's it. We have to go to the 2 ones. So we could select this, and also we could select. Okay. Oh. Let me show you. These 2 could be together. These 2, look at here, this one and this one. So these 2 could be together. What else? For example, this one, and this one, they could be together. I will show you later. That would be better map. What else do we have? This one. I guess that's it. So let me see if I'll missed something. So these 2 with these 2. Oh, okay, I missed somehow here. This also is another implicant. These 2 1 together. So we have 1, 2, 3, 4, 5, 6 implicant, and they are all prime, because none of them would be fully covered by other implicants, fully covered. So they are all prime. But which one is essential? So let's find the essential ones. Essential, I put highlighter there. So this is essential. This is one which is not covered by any other implicant other than the green one. And this is also a one which is only covered by the horizontal, I guess, blue one. What else do we have? This is not essential because it has been covered by 2 implicants. One of them is this one, the other is this. So this one is also covered by more than 1. This one is also covered by more than 1. So we don't have more essentials. We had 2 essentials. We write them. But now we have to select prime for the other ones. Yes?
I'm just kind of curious, because we have 6 prime implicants in total. Can we just ignore 2 implicants and just say that we have 4 essentials?
We are trying to do this. But how are you going to, which one are you going to ignore?
Well, we know that with 2 or 4 of the prime implicants, they basically are overlapping each other.
Yes.
So we could just remove 2 so that they don't overlap.
As selectively, just whatever. Yeah, that.
It's arbitrary, isn't it?
That's right.
Either one.
That's exactly what I have written here. That you could select. That's.
So for the course of this, it is important to highlight all the prime implicants.
Yes, fair, because you don't miss anything, and you could select the best one. Sometimes it's good to select the best. But you are right. When you have more practice, then looking at that, you can say, okay, this would be enough for me. I don't need more implicants. So as David mentioned, we could select. We have so many options for the 3 ones that are left here. We have 3 ones which are not covered by our essential prime implicant. We have options. One option would be, for example, using this and the yellow one. The red one with yellow one. This is an option, and it is already covered everything, which is not bad. Okay, so we can do that. You see here, this one and this one. Oh no, we have selected another one. It's okay. We could do that. You could select something else. You could select this prime implicant with this one. This is another option. It's okay. And also, you could select these two. All of these three are okay. The same thing. It works for us. It covers all of our ones, and we cannot find anything simpler than them. So they are okay. All of these three would be okay, whichever you want to select. Yes?
So then the implicant can't cover more than one other?
It can. Well, which implicant do you mean?
Because there's three scenarios, right? So like let's just say the top left corner wouldn't be able to cover both the bottom left and the bottom right.
Yeah, we did that. This one. You mean this?
Yeah.
This. Okay.
But in all together, not like there's different scenarios. But
We don't have one here. If we had one here, that we could also use these four together.
but in the same scenario,
What do you mean by same scenario?
like in the same equation, like I guess there's not more than one like square, so there's only one option to.
You know what I did? I selected essential prime implicant, okay? Then we saw that after those essentials, three ones are left, which was here. This one, and this one, okay? So you have to select implicants which cover these three ones. So what is your selection? What do you select?
That's why I'm asking the question, because I don't know how many you can select. Like in the top there,
It seems that we have to select at least two more implicants, because if you select this implicant, this one, the yellow one, then this one is left. So we have to select another implicant which covers that. So for this one, you could either select this implicant or either you could select this implicant. You know, you have lots of options. Yeah? No. Let me bring this here. We missed these three. We have to select something. Okay? For covering these ones. We cannot leave them. We have to cover them. What do we select? The best map you find here to select this. To me, the best one, we have all four more implicants: the dark red, the light red, the yellow, and the blue. Do you see these four? What I mean? This is the dark red, this one with this one. This is the light red, this one with this one. This is the yellow, these two ones, and this is the blue. We have four more implicants. Using these four, make a combination that covers these three ones. Whatever you want. No, one by one. Here you see, for example, selecting these implicants, we cover this one. Selecting this implicant, we cover these two. So they are all now. They are all complete now. So it's okay. Okay? No, there is.
I think I would see it in the equation format.
Don't think about the equation. We just thinking about the ones. We are looking at ones. We want to cover all the ones, and then we reach to the equation later. But now we don't have any equation. We just have min terms. There are min terms here, ones here, that we are trying to cover all of them. Okay. So now, as I told you, there are three ones left. You should cover them because these are already covered. It was very simple. With these two implicants, we have already covered these ones. but 3 ones are left. We have to cover them.
There's 3 different ways to cover the 3.
More than 3. I guess, yeah, I guess more, because this is one, this is another one, this is another one. Another one could be, for example, using, let me show you another one. For example, this. Oh, okay, I have it here. No, maybe this only the 3. Let me see if I could find something else. Yeah, might be. Yeah, might be. But I guess you could think of that. Yeah, these 2, either that or that. So these 2, either that or yes, because it seems that. Yeah, it seems that, yeah, only 3. I can't think of anything else. Here is 3 options. You have 3 options. And the equation is written down. Okay, another example. Do we have time for this example? Yes, we have 3 minutes. Okay, this, we will use our torus to find the adjacent terms. If we use our torus. Here is the, yes?
I was just kind of curious for that last example. Is there like an optimized set that we can choose, or we can
Both
choose any?
all of the 3 are the same. Yeah, you see why they are the same? Because you see they all have 2. These 2 is common. All of them, yes, and the rest, both of them has 2 more mean terms with 3 laterals. So 2 more product terms, not mid terms. So they are all the same. Okay. Now we are thinking of finding the implicants here. The first one that I am going to use is these 4. Now look at, could you find any more 4 combination of 4? I can't. Yeah. So we have to go to 2. So for 2, we have this, we have this. What else do we have? Nothing. That's it, yeah? Which one? These 2, you mean? This and this? Oh, yeah, yes, this one. Yes, you are right. This is also another implicant. You are right. So let's put a color for that so we know that. So this is the 4 one. So these 2, and also, as you mentioned, the other 2, which I didn't draw it because these will cover everything, and didn't do that. Here, let's see which one are essential. The blue one is essential, of course. It has these, which is not covered by anything else. The green one is also essential because of this. The yellow one is not essential because it has something in common with the red or with the green. The green one, the red one. The red one is not essential because it has something. It has already covered. This one is covered. This one is covered also. So it is not essential. So our essential, we have 2 essentials, and if we write these 2 essentials, which would be B not D, these 4 would be B not D, and the green one is D A D A B. Yes, this one. This one is the green one. B not D is this 4 one, and then we have to select. Now we have covered our essentials. Now we could select what is left. I guess we have already covered these. Only this one is left. So for this one, either you use this implicant or this implicant. Here, the yellow one is A, C naught D, or here you could use the other implicant also. Okay, this was another example of a torus. You have to look at the corners also, this, they are combined together. Okay, perfect. Very good. Any questions? Have a good day.